Hi students, this is Mr. Yao. Today in this lesson, we are going to talk about the next part of matrix, which is called determinants of matrices. First, let's review something we have learned. Let's do some prior knowledge. Decide the dimensions. We're going to decide how many rows and columns these matrices have. So, for the first one, A, 2 rows, 3 columns. Again, we're not going to write the word by anymore. We're going to use the cross multiplication sign to actually represent the word by. So it's a 2 by 3. B, 2 rows, 1 column, so 2 by 1. C, 2 rows, 2 columns, so 2 by 2. D, 1 row and 3 columns, that's a 1 by 3. Moving on, let's multiply some matrices. That's what we learned in the last lesson. First, again, decide the dimensions. That's a 2 by 2. That is a 2 by 2. That means my inner dimensions are the same. So yes, we can multiply. And also, again, reminder, that means we have 2 pairs of numbers in each space. And then these 2 outer numbers, that's going to be our dimension for the multiplication for resultant. So let's set it up. It's a 2 by 2 matrix for the result. And we're going to draw 4 spaces, 2 rows and 2 columns. Next, time to deal with the rows in the first matrix. Negative 1, 0, negative 1, 0 in the first row, 1, 2, 1, 2 in the second row. And then the second matrix, 1, 0 in the first column, 1, 0, 1, 0. Second column, 2, negative 1, 2, negative 1, 2, negative 1. Lastly, multiply and add. Multiply the pairs, add in between, multiply the pair, add in between, multiply the pair, add in between, multiply the pair, add in between. That's going to give us a result of negative 1 in the first space. Negative 1 times 2 is negative 2 plus 0, negative 2. 1 plus 0 is 1. 2 plus a negative 2, that is a 0. That is E. Next, F. Same thing, start with the dimensions. That's a 2 by 3. That is a 3 by 3. So we're going to have inner dimensions of 3s. That means we have 3 pairs of numbers in each space. The result right here, 2 by 3. So let's make sure we have enough space. Draw a big one. 1, 2, and 3. 1, 2, 3. Let's deal with the rows. First row, negative 1, 0, 1. Negative 1, 0, 1. Negative 1, 0, 1. Negative 1, 0, 1. Second row, 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. Second matrix. First column, 1, negative 2, 4. 1, negative 2, 4. 1, negative 2, 4. 2, 3, 5. 2, 3, 5. And third column, 3, negative 1, 6. 3, negative 1, 6. Oh, sorry, not 3, negative 3, negative 1, 6. Okay. Next, we are gonna multiply, 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 add. Multiply, 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 add. Multiply, 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 add. That's not multiply, add, multiply, add. Multiply. Okay. Multiply, 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 add. Multiply, 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 add. And that's going to give us a result of, that's negative 1 plus 0 plus 4, that's 3. Negative 2 plus 0 plus 5 is a 2. That's a 3 plus 0 plus 6, that's a 9. Then 0 minus 2 plus 8, 6. 0 plus 3 plus 10, 13. And 0 minus 1 plus 12, 11. That is F. Keep going. Next, let's get into determinants. Before that, square matrix. Square matrix, just like it sounds in the name, it's got to be a square shape. A matrix that has the same amount of rows as the amount of columns. So that's what makes a square matrix, like a 2 by 2 or 3 by 3 or 1 by 1 or 4 by 4. Determinant. It is a unique number associated with every square matrix. Gotta emphasize on that. If it's not a square matrix, you can't find a determinant. A unique number associated with every square matrix that categorizes some properties of the matrix, which is related to the real applications that we will learn in the future. The determinant looks similar to a matrix, but it has different notation. Instead of using brackets, the determinant is represented by 2 vertical lines, just like the absolute value lines, or we can use the word det to represent the matrix, the determinant of the matrix. For example, let's say you have matrix 1, 2, 3, 4. The determinant of that is going to be either using the bars, like right here, or you can write the matrix but have the word det in front of it. So to find a determinant of a 2 by 2 matrix, simple, we're going to multiply A and D minus B and C. So multiply the diagonals and then subtract. So let's have a look at some examples. AD minus BC. Multiply the diagonals. So 3 times 2 minus 1 times 4. And as you can see, that notation means is asking us to find a determinant, which is 6 minus 4, which is 2. It is as easy as that. Example 2, it already has the word det, so that means we're trying to find a determinant. Diagonal, subtract each other, so negative 6 times 2 minus 1 times negative 3. Or if you want to write it as negative 3 times 1, make sure you have the negative sign with the 3. So this is going to be negative 12. It's minus a negative 3, so it's a plus 3, which is negative 9. Example 3. So we can try to find that. Well, here's a diagonal. However, if you look at it, that's a 2 by 3 matrix. It's not even a square matrix. So NA, not a square matrix. It has to be a square matrix in order for you to find a determinant. Otherwise, you can't. Next, diagonal, subtract each other. 1 times 5 minus 0 times negative 1. That's 5 minus 0, which is 5. Last one, multiply diagonal, subtract the other one. So negative 1 times negative 3 minus negative 1 times negative 2. Be very careful. Make sure you have every single one of those negative signs. The negative signs, they need to be there with the number. And the middle is still a negative sign, a subtraction sign. So this is going to be a 3 minus negative 1 times negative 2 is a positive 2, which gives us an answer of 1 for the determinant. And that's example 5. And that is actually everything for determinants. Thank you. You will learn 3 by 3 determinant next year. Thank you.